So part one of our pressure exploration was looking at the relationship between pressure and volume. And before we look into the specifics, there's one note I need to make. There's something that's called STP, which is considered standard temperature and pressure. Standard pressure is 1 atmosphere, or we could say 760 millimeters of mercury. Standard temperature is 273 degrees Kelvin. We don't know about Kelvin yet, but I just wanted to throw that out there, that standard temperature and pressure is 1 atmosphere, or 760 millimeters of mercury, and 273 Kelvin. So here's kind of a quick summary of what we found during part one of the pressure exploration. We found that the relationship between pressure and volume is considered an inverse relationship. That means if one goes up, the other is going to go down. So if our volume's going up, our pressure is going down, and if our volume's going down, our pressure is going up. And here's what our graph looked like. It looked like a curve. Yours might look a little bit different, but it should have that same general curve. So if we have a high pressure up here, we have a low volume. And if we have a low pressure out here on the curve, we have a high volume. And we're going to use this relationship to solve a couple of problems. So we're going to jump right into our first example. And our first example says, you have a 2-liter container at a pressure of 1.5 atmospheres. What will be the new pressure if you increase the volume to 2.5 liters? So for each of our problems, we have a table here. And each column represents one of the variables. In this case, we're only going to be looking at pressure and volume, so we can cross out T and N, because we're not going to be concerned with those. So then our rows, we have initial, what we're starting with, final, what we end with, and then effect is how we're going to predict what's going to happen. So we have to fill in our numbers. So we have a 2-liter container. So we put 2 liters in there at a pressure of 1.5 atmospheres. So we've put in our initial conditions. What will be the new pressure, so that's what we're looking for, if you increase the volume to 2.5 liters. So our volume is going up, so we're going to draw an arrow in the effect, because we said our volume increased. It went from 2 to 2.5. Now we know if volume's going up, our pressure is going to go down. So we put a down arrow. So now our table's filled out, and we're going to use this to guide our problem solving. So the first thing we're going to write is the number that we're trying to find the new value of. So we're trying to find new pressure, so we're going to start with our old pressure. And we're going to multiply it by some factor. In dimensional analysis, you say, well, we're going to put atmospheres down here and then convert it to another unit. Well, we're not really converting our units. We want it to stay in atmospheres. But we want to figure out what's going to change our pressure. What's going to change our pressure is our volume. And we said that our volume, so we're going to use liters here, and now we have to figure out where our numbers go. If volume's going up, pressure's going down, this number, our final answer, needs to be lower than 1.5. So the question you need to ask yourself is, how can I put these two numbers in these spots to make this number go down? Well, you're going to put the smaller number over the bigger number. And then if we type it into our calculator, 2 divided by 2.5 times 1.5 gets you 1.2 atmospheres. So if you want your number to go down, you want the smaller number on top and the bigger number on the bottom. If we wanted this to go up, we'd flip them and go the other way. We can always double check ourselves, because we said our pressure should have gone down. Our final pressure is now 1.2 atmospheres. Did it go down? Yes. It went from 1.5 to 1.2. So 1.2 atmospheres would be our answer. Let's look at a second example. Our second example says you have a 2-liter soda bottle and the current pressure inside is 745 millimeters of mercury. What will the new volume be if you increase pressure to 800 millimeters of mercury? So we're going to fill in our values. So we're not looking at temperature, we're not looking at N. So we have a 2-liter soda bottle, so that goes in there. And the current pressure is 745 millimeters of mercury. What will the new volume be? So that's what we're looking for. If you increase the pressure to 800 millimeters of mercury. So we filled in our numbers. Now we have to do our predictions. We have to look at our effects. So what's our pressure doing? Our pressure is going up. And so what's our volume going to do? Our volume's going to go down. Because if pressure goes up, volume goes down. So you should be asking yourself, what's next? Well, we're trying to change one volume into a new volume, so we're going to write that first. Remember, we're not changing our volume units, we're just changing our volume value. So we're going to use our pressure units here. They'll still cancel out because they're on the top and the bottom. So now we have to figure out where we want our numbers to go. Well, if we want our volume to decrease, we need our smaller number on top and our bigger number on bottom. Because if we divide 745 by 800, we get 0.93125. We get a number smaller than 1, so that's going to make this number go down. So then if we multiply that by 2, so all I'm doing is I could do 2 times 745 divided by 800, and I get 1.86 liters as my answer. Now, the very last thing I want to do is go back and check, does that answer make sense? Well, I'm starting with 2 liters, and my pressure is going up, so my volume's going to go down. And so, right? Yep. Pressure is going up, volume's going to go down. We calculated 1.86. 1.86 is smaller than 2. So there you go. You're going to use the same process for all of these PV problems.